This is notes 11B for IB Chemistry HL11. It's going to be over relative mass. Here on page 67 of your textbook, there's a great definition of relative atomic mass. Relative atomic mass of an element is the average mass of an atom of the element, taking into account all the isotopes and their relative abundance compared to one atom of carbon-12. Since this is relative or compared to something else, a proportion, if you will, there is no unit technically on the mass that is listed. Carbon has a relative atomic mass of 12.011. Why is it not exactly 12? Well, by definition, the isotope carbon-12 has a mass of exactly 12, but there is some carbon-13 and carbon-14 that also exists, and so the overall average is slightly larger than 12. Most of the carbon out there is carbon-12. A few of the atoms out there are slightly heavier. Understanding how a mass spectrometer works is no longer part of the IB exam, and it was never part of the AP exam. However, here is a diagram. It's also in your note packet. We take a sample. We heat it up until we can turn it into a gas. We have an electron beam, which helps turn this into ions in here. And then because those ions have a charge, we can accelerate those in a magnetic field. When we expose that to a cross-magnetic field, these ions are going to bend in their path. The heaviest ones are going to go the straightest, and the lightest ones are going to bend more. And so they end up separating by their mass, and we can count the hits down here and get a percentage of how many molecules are the heaviest, what percentage of the molecules are the lightest, which ones are somewhere in the middle. And they can break that down per isotope and get a sense of what's the average mass based upon these percentages of each isotope in samples. Okay. The rest of your notes are example problems of looking at mass spectra. You'll find the first one here at the bottom of page 67. Reading the diagram, it looks like we have two isotopes because we have two peaks. One of a mass of about 85, seems to be 77% of the sample, and a heavier isotope with a mass of 87, right here at 23. To find the relative mass or the average mass of this sample, we simply take the mass times the percentage, do that for both sets and add them together. When I do the work, it's going to be 85 times 0.77 plus 87 times 0.23, and that keeps me from having to divide by 100 at the end. 85.46 would be the answer, and this work is detailed in my written out notes. The second example problem is a little trickier algebraically. We have two isotopes of boron, boron 10 and boron 11. If we look at the periodic table, the average mass of boron is 10.81. So we can use this information to figure out the percentages. This is also detailed in my written out notes that you have access to. We do need two equations that we can substitute into each other. I know the two percentages have to be 100% since there's only two isotopes, so I'll make use of that. I also know that 10 times the first percentage plus 11 times the second percentage needs to be this number on the periodic table, 10.81. So taking that to account, we should find that the lighter isotope is about 19%, and the heavier isotope is about 81%. That makes sense. If they were 50-50, we'd be at 10.5. Our average is much closer to 11 than it is to 10, so I would expect the 11 to have the more abundant isotope and the 10 to have the less abundant isotope. Don't forget to do the second part of the homework assignment, 11B. That's page 68, 7 through 11, which we can see right here. And on page 93, question number 2 and question number 11 at the end of the chapter. The second half of class today is going to be grading this assignment, as well as looking ahead at the quiz that you can take today, and you'll get a review guide that has a bunch of old AP and IB exam questions on this subject.